All right. Hey, everyone. This is Mr. Who here with the skill number 3 for Algebra 2 Semester 2. Okay, talking about inverses today. And we will see from this lesson that they're not too hard. Okay, there's two ways we're going to talk about finding inverses. That would be algebraically and then also graphically. So those are the two modules, or I guess a couple of modules we'll be working with here in Delta Math. So I'm here to tell you all the basics about inverse functions and how to do them. Okay, so first of all, what are inverses? Okay, you can think of them as kind of the opposites. Okay, opposite of a function. Okay, for every function there should be an inverse. All right, and kind of a concrete way, something you might be more experienced in. You know, thinking about it is if you have to make a sandwich, if you want to have a sandwich for lunch, okay, you got to take out the bread, you got to take out the meat or whatever you put in your sandwiches, okay, lettuce, tomato, onion, if you BLT, all that other good stuff, and when you put it together, you get a nice complete sandwich, the output, okay. Well, an inverse would be like taking your complete sandwich and taking all the pieces apart and having your ingredients back. So reversing that kind of process, undoing, okay, that is synonymous with inverting here. Okay. Um, Hopefully that was something that you can relate to. Um, and so in math anyway, okay, in math anyway, which is the real important part here, it's as simple as just switching your x's and your y's. So your x's and your y's, you just switch the places of them. Wherever they appear in the function, you can even do it with points on a graph, all that other good stuff. Okay. You just take those two things and you switch them. Okay. We'll do a couple examples here, so we will kind of see that in the process. Okay. However, you do have to watch out when you do the swapping in the function. You have to solve for the y because functions are usually defined in terms of y. We usually want y by itself in order to make the function a little more easy to read. Okay. So let's get to our example here. All right. So we've got our function here, starting simple with a linear function, y equals 4x plus 8, all right? Um, and so I'm just going to go ahead and do what we just said, okay? I'm going to invert this function, which means I just replace all the y's with x's, okay? So here we go. X equals 4y plus 8, okay? And it really was that simple. So this is the inverse here of that function, okay? Inverse of that function. Now, remember I said you had to solve for the y if you do it this way, okay? Now, how do I solve for y? This is going to take a little bit of remembering on your part, but it's just some basic algebra solving equations, okay? So our first step would be to undo this adding 8 part. So let me change the color of my uh, pen here so I can tell you exactly what the steps are. We've got minus 8 in order to get rid of our plus 8. What you do to one side, you got to do to the other. So here's minus 8 on this side, right? Kind of a mediocre 8, but you know, it is what it is. Okay. So when you do that, you should end up with the next step being 4y equals, because these cancel, right? X minus 8. Okay. And of course, let me know if my camera's in the way. I'm trying to make sure they're not in the way. So if it is in the way a little bit, I'm sorry for that, but I'm trying to keep it all Gucci here. Okay, so x minus 8 equals 4y. Now, last thing I need to do before I get y by itself, of course, is to undo that multiplication, that pesky multiplication. How do I do that? Of course, the opposite of multiply is to divide. So I divide by 4 on both sides. Alrighty. And with that, I'm going to cancel out my 4's here. Okay. And I'm left with y equals, okay, x minus 8 over 4. You can't really simplify that here, so I'll just put x minus 8 over 4. Technically, you could split that off and become you could turn this minus 8 over 4 into a 2, but it doesn't really matter since these are basically as simple as it gets in both ways. Okay, so this would be my inverse function. I can do the appropriate boxing there. It's a little messy, but I'm still getting used to it. I'm sure if you got questions, you'll bring them up to me. All right. And that's really it. So let's kind of erase our work here. I'll let you pause it, of course, to clean it up if you need it. But, okay, when we're talking about, oops, okay. So when we're talking about solving these kinds of problems, okay, you use these inverse operations. So, as opposed to just inverse functions, we also have to invert our operations in order to undo those as well. So, for example, subtraction undoing addition, that's what I kind of just did there, and division undoing multiplication, uh, that kind of follows as well. And those are processes that also invert each other. So if you're subtracting a number and you want to move that away, you can add to get rid of it. Okay, just make sure whatever you do to one side, you do to the other. All right, basics of solving equations, right? All right, so let's get a little more challenging here. Let's do a little more challenging ones. This, of course, is a rational function. You should know that from your parent functions notes. All right, and we're going to go ahead and solve this one, or I guess find the inverse of this one, okay? All right, so the very first step, the easiest one of all of them, again, is just swap your x's and your y's. So y on the left turns into an x, and x on the right becomes a y. Y plus 2 minus 4, just like that, right? All righty. Now, let's go ahead and do some of that inverse operation stuff. Okay, change my color again. All right. Well, I know I'm subtracting 4 from that right side. I definitely don't want that, so I need to add 4 to get rid of it. Add 4 to both sides. All right. So let me go ahead and write the next one so I get the right color. Hey, hey, hey. Okay, there we go. And we got x plus 4 now on the left, and then we have 3 over y plus 2. Now, y plus 2 is in the denominator. So how am I supposed to get that out of the denominator so I can get y by itself? Well, there are a couple ways to go about this. One, you could multiply the whole thing by y plus 2, thus undoing the division there. Okay, that is definitely an option. But I think the more, I guess, efficient way is to put your left side over 1 and just cross multiply. So let me use a different color for that as well. Okay, so I'm going to cross multiply here. All right. So when I cross multiply, I should end up with this x plus 4 times y plus 2 on the left, and 3 times 1 is just 3, so we'll just leave it 3. Okay. Remember to keep parentheses around your terms here, because we don't want to lose that idea that those are just numbers. Okay. So x plus 4 and y plus 2. Well, now these two things are being multiplied, so I need to divide. All right. Let me go ahead and move over here. It's going to be a little messy, a little cramped, but I'm sure you'll be able to handle it. Okay. Or I could clear it off. So go ahead and copy what you got here. Let me clear it off, and we'll start from that step, okay? All right. So we got the y plus 2 and the x plus 4. That's all equal to 3, right? So again, remember, since we're multiplying, we can undo it by dividing, right? Divide the whole left side by x plus, x plus 4 here. Okay. And same thing over here. You got to divide this by x plus 4 too. Kind of running out of space as well. Okay. So remember, just keep in mind, you got to do everything in equal chunks. Okay. So these two should cancel out for sure. All right. And you're left with just y plus 2 equals 3 over x plus 4. Okay. All right. Last step before you're done is to subtract off the 2. I'm not even going to really write that. I'm sure you guys know how that's going to work. But you cannot subtract these two things. Ooh, that's not a 2. Erase that here. Just a second. Boop, boop. Okay. So when you subtract the 2, just kind of keep it to the side there. All right. And this is our answer for the inverse. Alrighty. Okay, so I mean a lot of steps here and there, but it's just basic algebra. Okay, so if you need the help doing the basic algebra, definitely ask for the help there. Okay, just remember to keep in mind that you have to do to one side what you do to the other. That's the main point here. Okay, but yeah, once you invert, all this is just solving equations for one variable, and I'm sure you guys have done that many a time before. Might be a little rusty at it, or maybe you were never particularly like great at it, but I'm sure you can all do it. I believe in all of you. So let's go ahead and move on. Let's do another example of a multiple step problem here, one you will definitely see in the module. Okay, uh, yeah, so here's that cross multiplying step. You can do that as well. Okay, all right. So lastly, we have this idea of a square root function. Okay, you can definitely invert these as well. They are a little harder to grasp um, graphically, I suppose, but we're not really worried about the graphic part yet. We'll get there. Okay, but just like the other ones, we're going to go ahead and invert this function, all right? So I'm going to go ahead and progress through this problem, just doing the multiple steps I've been doing. But once I get to the new step, I'll stop and talk about that, all right? So first, I'm inverting my variables here. So I got 4 square root of y minus 12 equals x, okay? Then I need to add my 12 off to both sides in order to get rid of it. Okay, so now I should have something like x plus 12 equals 4 root y. Divide by the 4, whole thing. Okay. So that allows me to cancel out these dudes. And then I should end up with something along the lines of x plus 12 over 4 equals square root of y. Okay. Now, square rooting is a process that involves finding out a number that, when multiplied by itself, is equal to the number on the inside. Okay. Um, and that is a process that is inverted by squaring. So what we should do here, I will use a different color to indicate we're doing something new here, is to just square both sides. Okay, square both sides. All right. Now it is getting a little packed here, so please pause and write down any of that stuff you need. I'm going to write down exactly how this next step's going to go. All right, so we got x plus 12 over 4 squared, and then the square roots will actually cancel, leaving you with the y. And I think this is probably as simple as it gets. You might also see Delta Math simplify the denominator as something like 16. Okay, that's totally normal. Um, so I mean, you can simplify it that way if you need. But this is pretty simple, and I think it gives you the whole picture of what exactly the inverse of this function is. Okay, and again, this is a square root function. So when we invert it, it will look something along the lines of a squared function or quadratic. Okay. Alrighty. I hope that's, not too much for you guys to stomach. I would definitely recommend going back into the video and looking up the areas you definitely have problems in, um, such as the multiple step ones. I think in general the single step, or not the single step, but the linear ones are probably not too hard on your brain. All right. Now we're gonna move on to the graphing. All right. So let's move on to that. Okay, so here we have the slide for inverses by graphing. Now, you may not be given the function like algebraically to look at, and so this is where this method kind of comes in handy. Okay, so if you don't have a whole lot of algebra at your fingertips, this is definitely the method you might prefer for visual, purposes as well. And it actually just uses points from the original function. So as all you need here is just a graph, a visual of what the function you're trying to invert is. So let's head over to Desmos and look up this example here. So here we are at Desmos. Okay, I've got this function here, parabola quadratic. Okay, and you might even be noticing some points already. Okay, so let's go ahead and make some points for this graph. We got -2, that'll give us a 0, right? We got a 0, which will give us a 4, maybe -1, looks like that gives us 1. Let's do even this -3, that's 1's all right. Okay, and one more. Let's do one more. How about -4? Okay, so I got all these points, right? And so just like with the functions, the algebraic functions, okay, you can simply inverse by flipping the x and y. You can switch their places, okay? So when I talk about the point -2, 0, for example, to flip that point, I would need to look at 0, -2. Okay, so let me actually pull that up. All right. So here's 0, -2. So that is pretty much the way you invert points. Okay? So I'll go ahead and do the same for all these other ones. We got -1 and 1. Okay, so that would be something like 1 and -1. Okay, good so far. We got -3 and 1. So that's something along the lines of 1, -3. Okay, it's looking good so far. We got 4, 0 up here, or not 4, 0, 0, 4, my apologies, which actually turns into 4, 0, the one I just said mistakenly, but there it is. And then finally we have this -4, 4, which should turn into 4, -4. Okay, so you can see the shape similarities here, okay, and we'll talk about why that is. But if you're doing this on Delta Math, you're following along to help you with Delta Math, this should actually automatically fill in on those sections. Okay? But for me, I don't have that luxury, so I'm going to need to make a graph. Okay, so I'm back. Sorry for the cut there. Okay, but this is something along the lines of what you might expect a inverse function to look like graphically. Okay, so as you can see, it's kind of the same shape, but it is turned over. It is flipped over, and that's because the special property of inverse functions, okay, is that they are actually the reflection in this type of line, y equals x. Okay, so if you can remember this line here, okay, the y equals x line, all right, any function in the plane can be inverted by flipping it over this, reflecting it in that line y equals x, okay? Um, you don't necessarily have to know that, because if you know the points getting reflected and the values of those, you'll be fine and dandy on your own, okay? But that is pretty much how this graphing by functions, or graphing inverses kind of goes from the graphs of the function you're inverting. I think I said that right. So that's pretty much all for today's notes, okay? So if you got any questions on the notes, please stop by. Drop us an email, drop us a message, okay? Um, work through it, right? If you have any questions on the modules, right, during class, you can always ask that as well. All right. Thanks for hanging with me, guys. I will see you guys next time when I do skill 5. I'll hand it back over to Mr. Bear for skill 4. Bye-bye, guys.